Hi, everyone. So this is a pretty simplified animation that I'd like to go ahead and walk you through regarding cell division and mitosis. So we'll take a look at it real quick. For one, the bottom line is mitosis is, of course, taking one cell and turning it into two cells. But the important part is the genetic material. So let's go ahead and walk through piece by piece. So we begin, and this cell would be considered to be an interphase, the part of the cell cycle where it's not actively dividing. Technically, during interphase, you would not see chromosomes. They would not be condensed and coiled up, and therefore they would not be visible. They'd rather be in the state called chromatin. But this simplification has put it together as they are in chromosomes, just so that you can go ahead and see what's happening. So when we begin, we are in the interphase portion called G1. This is where normal cell growth happens. The cell is really just doing its job, whatever that job is, depending on what kind of cell it is. When we get to S, or the synthesis part, we see that the genetic material doubles, it duplicates. This DNA replication, this event that you guys learned about from chapter 7, is essentially taking a look at how DNA can make a perfect copy of itself. And in making that perfect copy, we now see that these chromosomes look like little X's. They're sort of doubled up in material. When we then get to G2, the final part of interphase, the cell is ready to divide in that it's got a duplicated amount of genetic material. And that's really important so that each new daughter cell has the right amount. Now, prophase, this is the busiest phase. This is the phase of mitosis that most of the heavy lifting and the work happens. So what's going on here? Well, the nuclear envelope has broken down completely. The nucleolus has been removed and sort of dismantled. We see these little structures here, which are called centrioles. These are starting to move to the poles during prophase, and spindle fibers are starting to develop. The chromosomes are coiled and condensed, and we can now visibly see them. And then they make their way to the middle. This here is metaphase. Metaphase means that everything is lined up in the middle. The purpose for lining it up in the middle is so that when the division happens, there's perfect amounts of genetic material in both of the two new cells. That's sort of the key thing here with cell division. Anaphase, I call this the phase of movement. Anaphase begins as soon as that centromere splits and those sister chromatids start to get pulled away. And anaphase ends when these chromatids reach the poles and they sort of get as far as they can get on either side. And then we go into what's known as telophase. Telophase is the last phase of mitosis, technically. And this is where you'll start to see the nuclear envelope reappear and the chromatids start to unwind and go back to that chromatin state. And the nucleolus reappears, and then the cytoplasm splits. That's cytokinesis. So let's take it one more look. So just a quick overview. We go from having one cell to two perfect identical daughter cells. I hope that helps.